A nonlinear function. We're going to talk about nonlinear function. This is a vocabulary word. Is this common sense? Would you know what nonlinear means?
Nope.
Okay. How about if I did this?
Yes.
No line.
No non-line.
So a nonlinear function, you see this in your notes, you're going to have to fill something in, is not
a function.
Not a nonlinear function is a function that is not what? It's not a
linear function.
Oh,
Line.
not a line.
Line.
Okay, guys,
Line.
go ahead and write that in there. It's a function that's not a line.
Okay.
What's a function, you guys remember? Usually it actually shows up on a graph. You guys learn equations and you learn graphs. An equation describes a graph, and a graph describes an equation. Okay, they go hand in hand. It's like what a graph or an equation is like the name of a picture. Does that make sense?
Mm-hmm.
Okay. So now we're going to talk about a quadratic function. Okay. Now you guys, we've done a lot of quadratic equations, and this was the general form of it. Do you remember ever seeing this before? It actually looks like a trinomial, doesn't it? With just generic variables, but usually there's a number here, right?
Yeah.
There's always an X or a letter. This is usually any number, like 5, any number.
2.
So this is a general one. So this is just referring to any such type equation. Okay? And it says where A is not 0. What would happen if A was 0?
Everything.
Then this whole thing would be 0, right? If A was 0, what kind of equation would we really have? It would look like this, right? Bx plus c, which looks a lot like, what kind of equation is that?
A graph
Of
y equals.
Oh,
It's a line graph.
Yeah,
it's a line.
this is a linear graph. Anytime you have a number and an x and a number, or a number with an x with no exponents, it's linear.
I did not know that.
Yeah, so this is always linear, just different letters. These are all just letters we make up, like someone's name, Bob, okay? So that's why if A is not 0, now we have a quadratic equation, or quadratic function, not a linear function. And a quadratic function describes a different sort of picture. A linear equation has this sort of picture, right? Here's a general one. That's a linear equation picture. Yes. Oh, and I'm going to teach you that. I forgot. A quadratic function shows us a different picture, and it's in your book. And we will do a little mathercise on this. It would look something like this. This is a picture of a quadratic function. It's a curve. These are all examples of a quadratic function. Do you see what they all have in common?
They all curve.
They all curve, and where they start, if they're pointing up,
They always
they
go
end
to
point
the,
up, right?
Yeah.
If they started pointing down, it ends pointing down. So they all have a minimum. They're all hills, right? A minimum, or here's a maximum. They have a top or a bottom. Does a linear equation have a top or a bottom?
No.
No, it goes for all, ever and ever. So these are quadratics. Now, a quadratic equation, the most basic, we call it a parent function. Isn't that weird, a parent function? Here's a parent function for a quadratic.
What were we supposed to fill in, or where are...
Nothing yet. Okay, I'll get back to that. I'm just going to give you my little notes, or some visual. Here's the parent function of a quadratic. Or it could be, here's the same deal, right? These mean the same thing, different notation. Okay? This is where we like to use function and graph. Same thing, okay? So the graph of that looks exactly like this. Now we could make a t-table, which they did do. So if I were to graph this, you guys, when x is 0, y is 0, right? Jordan?
Mm-hmm.
When x is 0,
Y is
y is 0, right? So if we had a t-table, when x is 0, y is 0. What about when x is 1?
Oh, T table, I think.
Y is 1. What about when x is negative 1?
Negative 1. Negative something else. 1. Negative 2.
Oh.
Positive 2. 1.
Yes, good.
It was 1.
Positive 1. Yeah, positive 1. Good. Thank you, Isaac. And then what about when x is 2? 4. And when x is negative 2? Positive 4. So this is the parent graph.
Oh.
And if we moved it over, we could move it over, we could move it to the left, we could move it up, or we could flip it over. So let's look back at your notes where it says number 1. A quadratic function is a function of the form ax squared plus bx, where a equals 0. They are called, oh, I just drew you a bunch of pictures of these. Do you know what those pictures are called?
Linear, nope. Nonlinear functions.
Let's see if we can pronounce this right. Those curves were all called this.
Parabolas.
Close.
Parabolas.
Close. It's, here's the accent.
Parabolas. Wait,
That's
what?
word in Spanish.
Parabolas. Parabolas.
Oh,
Okay?
parabolas.
Parabolas. That's a parabola. Those curves.
Parabola.
Parabola. Say it 10 times fast. You're going to hear about parabolas.
For the rest of
Until,
your life.
I don't know, you graduate from high school.
Oh.
And maybe even more because you're all going to be math.
Parabola.
Notice the degree of this.
Oh, wait, what am I doing?
Notice the degree of the function is what. Do you guys remember what degree means? Vocab word that we've discussed in the past.
Fahrenheit.
Yeah, that is not temperature.
I mean,
what's
it's,
the degree of a function?
It's the number on the top.
Yeah, the highest exponent in the function is your degree. What's the degree of a quadratic?
2.
Yes, the degree is 2. So in the notes there it says in star, notice the degree of the function is 2.
Ooh.
And I do want you to look at those pictures.
Pictures.
They gave us 4, because once you learn this, I'm always tutoring people on this in advanced algebra,
It's good looking.
because they must not have learned it the right way first time. So here's the parent function. You remember I told you that? 2, 4.
Parent.
That is the parent function f of x equals x squared. Okay, here, now we're going to move that same parent function over 3. Every point we add here is going to move over 3. Or I'll just do it in a different color. Let's move it over to 1, 2, 3. 1, 2, 3. Sorry. And it's like this. Right? You see it? I moved the parent, basically. He's supposed to be right there. Do you all see that in orange?
Mm-hmm.
The parent function moved to the right. Do you know what the equation is for this? This is funny because it's opposite of what you would think.
Y2. Wow. -3. You would think it'd be plus.
You would think it would be plus because we went to the right, but it's the opposite. So do you notice how the 3 is involved in here? So it's squared. Now what if we do, take it down 3, different color. Let's move the parent down 3 spaces, 1, 2, 3. And 2, 1, 2, 3. We go through here, and here. Okay, so the green one is the parent function down. You want to know what that looks like? F of x equals x squared minus 3.
Wow.
Interesting. So I just want you guys to notice the pattern today. And then the
Squares.
last one is they flipped it. Do I have one more extra, one more fun color? Now they take the parent and we just turn them over. Basically it looks like this. And that parent is not the parent anymore. These have all been transformed. The pink is the parent, and the orange and the greens are all transformations of the parent. Maybe they're children, I don't know. They're all forms of the parent function. Okay. This is negative x squared.
Negative.
So when it points down, we have a negative out front.
Negative. Okay. Makes sense.
Fun, right? I love this stuff. Now, those were all quadratics where the degree is 2. What if we have one that the degree is 3? What does that picture look like? The parent function of something.
It's always going to be
First of all, what's it called? I called it a cubic, right?
cubic.
Because anything to the third power we call a cube, right? So
Yeah.
f of x equals x cubed. That is called a cubic function. So should I transform that around too the way we did? Now, what's the degree? I said list a standard cubic function. Do you see that there? Here's the standard cubic function. F of x equals x cubed. Go ahead and write that in. Do you see where? Number 2, list a standard cubic function. Okay, I'm going to graph the standard cubic function for us. Are you ready? Are we ready? It goes through here. When x is 1, y is 1. When x is negative 1, what is y?
Negative 1.
Negative 1. Good.
That's cool.
So the way these actually look is this. There's the parent. F of x equals x cubed.
It's always so perfect.
So now, what if I wanted to do an orange? I want to do f of x equals x minus 3 cubed. Remember what happened with the parabola? When it looked like this? Did it go up 3, down 3, right 3, or left 3?
Right.
It went to the right. 1, 2, 3, even though we think it should go to the left, right? So here is basically that. All right?
Oh.
Now what if I did f of x equals x cubed minus 3? Up, down, left, or right?
Say again?
Is this one going to go up, down, left, or right from the parent? Here's the funny thing. When it's stuck in the parentheses, it goes opposite. When it's outside the parentheses,
It goes the way you're thinking.
it goes the way you think. And this is an up or down change. This is a left or right change. So we're going to go down 3. 1, 2, 3.
Okay.
And it's going to be those points. And it's going to look like this, basically. I say basically because it's obviously not perfect, right? I should have had a better curve. Yeah. Now the last one that we can play with would be f of x equals negative x cubed. What happens when we do a negative? Do you remember? We flip it.
Oh, so then it's going like this.
So it actually
This way.
have these points. If I take that hot pink one and flip it over, it looks like that, right?
That's a cool.
Okay. This works for all of our standard graphs. So that was our cubic. I'm sorry, this is going to be a long video. We're not going to do all 4 today. Okay, but this is really important because this is pre-calculus stuff too.
What was the degree? 3.
Big degree is 3, yeah, good. Okay. And then the next thing they show us is a square root function. So that was a cubic. Now we're going to look at a square root function. And the general parent function looks like this on the equation. And we call that I see a blank there. It's called a square, I didn't give you a lot of space, a square root function. And then I said, go ahead and see the shape of the graphs. This one's a little different than the other guys because it has some areas where it can't go. And I'll explain why in a second. It goes here, and here, 1, 1. It gets kind of like all the way out to 9. It's the square root of all these. So square root of 1 is 1. Square root of 2 is a little more than 1. Square root of 3 is up here, right? Square root of 4 is 2. Square root of 5, square root of 6, 7. If you go all the way out to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be right at 3, right? So this is called a square root function. Now on all the others, it went everywhere else, right? It went all the way left. It kept going
That way.
But why it stops right here? Why is that?
It's
Why
positive.
doesn't it go down here?
Because squares are positive.
Yeah, a square root. You can never have a negative in the square root sign. So x cannot be a negative number, can it?
Yeah.
Never. Can it be 0? Yes, you can do the square root of 0.
Yeah.
So it stops here. So now let's do the parent graph game again. If that's our parent graph, what if we did, do you see how this is always involved in the x and it goes the opposite direction we think?
3.
So it goes to the right 3. So we take all those points that we did and just move them over. Okay? Let's do...
Is there like some kind of professional name for the square root function? Or is that just it?
No, it's going to just call it the square root function.
Okay.
Yeah.
Just wondering.
I know, good question actually. You even made me look. Okay. Again, this goes now the direction we think it should. It goes down 3. What if this was plus 3?
I would think
We move it up. We're going to go down. 1, 2, 3. And this, and this, and then use. So it looks like that, right? Again, our x's are always positive. What if we had our other one, f of x equals negative square root of x. Not negative in here, but negative on the outside. Flip it. Flip the parent. Remember the parent?
It goes like this. Like this curve goes downwards.
Like that. Okay.
Pretty cool. Looks
All
like the
right.
alligator thing.
Now there's only one more type of graph we're going to look at. And it's a V. But we don't call it a V graph.
We call it the vertical.
What do we call it?
Vertical.
It
Starts with a vowel.
It does start with a vowel.
No.
Can I buy a vowel, please?
Vowel.
It is called, well here, it looks like this. Here's the parent function. What are these symbols called?
The whatchamacallit. It's the value.
It is value.
Absolute value.
Absolute. So this is the absolute value function.
That was exciting.
Good job, guys. And again, my parent is this, and it looks like this. So basically, when x is 0, y is 0. Oh yeah, you have to get
I'm gonna go
some. I told him you're gonna have a good movie.
I'm kind of brave with that scared.
Oh, yeah, no, he likes it. Okay. When x is 2, y is 2. X is 3. Basically, whatever x is, y is when we're positive. What if x is negative 1? I already did it. What if x is negative 1?
Go that way.
Then it becomes positive 1. Do you see what I'm saying? If x is negative 1, y is positive 1.
Hmm?
And all the way up. So it's a V.
Basically just the opposite.
Yeah. Opposite sign.
-1.
They're always positive.
3.
Okay.
Yeah.
So that's the parent graph. If you guys get the pattern now?
Yeah.
What if I have,
X
if,
and 3.
okay, let's do it this way. Let's see if you can decide, I want to move it to the right 3. 1, 2, 3. Let's see if you can figure out what the equation is for this.
Absolute value signs x minus 3.
Okay, so x is the minus 3 inside or outside?
Inside.
You got it.
Yeah.
Again, that's pre-calc students struggle with that. Okay, how about, what does this look like?
Because it still goes that way. Down though.
Yeah, we just shift it. We call it a vertical shift.
Positive.
Vertical shift down. Okay, and then the last one that we do is a negative.
Oh.
Down B.
This pattern.
Yeah, I like these patterns. Patterns are good, as long as you notice patterns.
Notice something usually be easier.
In fact, you learn math better when you notice the pattern and think of the rule than when someone shoves the rule down your throat. Discovery is better than
Forced
just being
discovery.
told, okay? You'll remember better with discovery than just being told. So, as Jordan might have noticed already, we haven't even started the examples, right? She's probably looking at the time.
What?
But we're not going to do all 4 lessons today, right?
Oh.
So again, now example 1. It says read the example on the bottom of page 398. They gave me an equation that I'm just going to really do a rough sketch here.
That's a
That,
W.
and something like this. Basically, right?
It's like that robot.
Okay. In these, the graph of a quadratic function, you see these, this is A, B, C. Which of these is an example of a quadratic? Huh?
That one.
Letter
Yeah. B.
B. What's this called again?
Quadratic.
And then what's the shape
Parents.
called? What's the shape?
Curve.
Parabola.
Oh, yeah.
Parabola, blah, blah. Okay? Good. The rest, I saw a linear function in there and then some that we don't have a name for. Okay, now it says,
W.
given the following functions, x cubed plus 1, absolute value of x minus 2,
B.
negative square root of x, and x squared plus x plus 1, identify who belongs with what. Does that make sense? So they're saying we got this,
Make absolute value
and we got this,
B.
and linear.
yeah, but I need to know, we're gonna do, okay, do you see those pictures there, top of 399? Sorry, Jordan doesn't. Top
Oh.
of 399,
Without a graph thing.
huh?
Okay, the first one is the quadratic. This B
So-
is I forgot. I think it was the.
A B, yeah, are you saying the first one is B? Look at, do you guys see, well, okay, A. Do you see the picture A there? What, are you with me on the top of page 399?
Okay, yeah.
Letter A, which equation belongs with letter A? Which one of these belongs with, letter A is a picture that looks like this, right?
Not
Which one of
FX.
these?
With
X.
L.
L, this is a quadratic. So
Yep.
this one looks like that, right? That's A. So A is x squared plus L of x equals x squared plus x plus 1. And you write it right there, right?
Why am I doing this with the red pen?
Okay, that's A. B is a picture that looks like this.
That's the grab the square root function. Is it the square root or is it the cube root?
That's a cubic.
Cube.
So that,
Cubert. Okay.
so letter B is f of x equals x cubed plus 1. So this was the answer for B. This was the answer for A. So now we've got, these two are our last left, right? Now the next picture looks like this.
Let's see.
It's,
It's cubic.
what's the equation that goes with it? And it's not
H.
cubic. It
So
is h of
it's-
it. No, sorry. What is this?
Oh yeah, that's absolute value.
Yeah, this goes here, and the answer to that is C. Okay, and obviously D then is this, right? But here's the picture they gave us for that. So do you notice these pictures all go with these types of equations?
Uh-huh. Cube. Your wave. Mountain thing.
Okay, the last one is another matching one. Letter A gives us a picture of a, what's that picture?
It's a cube.
It's a
Quadratic.
The parabola.
quadratic, and it's a parabola.
Parabola.
So which equation goes with that? X cubed plus 3, negative x squared plus
A.
5, 1 plus square root of x,
A.
or,
I think it's A.
no, this is A. What equation goes with that?
G.
A.
G of x, because this is always has a square in it.
Where's G? Wait, isn't it?
It's below those pictures. Do you see on 95.3?
Yeah.
Below there are the four equations to
Mhm.
choose from.
Oh, below them.
G of x is
Oops.
negative x squared plus 5. That goes with A. B looks like this, right?
Cubert. Cube.
It is a cubic. Cubic. So that's f of x. You write this f of x equals negative x cubed plus 3. And the letter C.
Wait, what? Oh, F.
And letter C has a picture of a V.
Wait, this is hard. It's hard not having a book.
Well, it's just here. It's because you're being impatient. There you go. I have it written okay.
Now you guys are ahead and I don't know what's going on.
KX. And the other one is non-KX. Oh, we go.
Okay. We're good?
Mm-hmm.
All right. That is the end. You can go ahead and turn on that. That's how you graph.
Parabola. Parabola.
Oh,